In section 3.4, we're going to talk about translations, and a translation is a type of transformation. A transformation is the movement of a figure in a plane from its original position to a new position. Now, a type of transformation is called a rigid transformation, and this type of transformation does not change the size or shape. So just think about picking up the image and moving it over. We're not stretching it out or pushing it in. Does not change the size or shape. It's called a rigid transformation. And there are three different types of rigid transformations. The first one is a translation. So that's what we're talking about in section 3.4. This is we're taking the image and we're shifting it up or down or left and right. And the second one is a reflection. So we're taking that image and flipping it over. It's a mirror image. And the last one is a rotation. So we're taking that image and turning it a certain amount. So all three of those are different rigid transformations. Another name for a rigid transformation, the first one is congruence transformation. So let's write these at the top. Other names. Congruence transformation. And then it is also sometimes referred to as isometry. But we will mainly refer to it as a rigid transformation. I just want you to be aware that there are some other names for that same thing. Okay, so let's look at the next part. When we do these rigid transformations, we refer to our original shape and our new shape as the pre-image, which is our figure that's going to undergo the motion of transformation, and then our image, which is the resulting figure from that transformation. So it's good to be aware of those two terms when we're starting these translations for 3.4. Okay, so let's look at our first example. Okay, so we have our translation, which is all points are going to slide the same distance in the same direction. So if we look, rectangle ABCD was translated 5 units up, or 5 units right and 2 units up. Now if you look at the points on our graph here, you see we have just a regular A here and then a little A prime. A prime looks like this. The little apostrophe, that's what we call that little symbol, the prime symbol, and that tells me that A prime is my image. So I started with this figure over here in red. This was my pre-image, and then I moved it 5 units right and 2 units up. And if you look at it, we can check our point B here. If we moved it 5 units right, 1, 2, 3, 4, 5, and 2 units up, 1, 2, this would be our new point B. Okay, and you do that with all the points to get your new figure. So another way to write this translation would be to write it as a coordinate point. So this is called coordinate form. And when we write this, let's title it coordinate form. So this would be taking our coordinate, x, y. So any coordinate, we could match this up with A, B, C, or D. And I'm going to draw an arrow here to show that we're transforming it in some way. And our transformation is to go right 5. So that means I'm going plus 5 in my x direction. So to my x, I'm going to have plus 5 in my x direction. And then up 2, that means I'm going up 2. I'm going to add 2. So 5 units right was plus 5. Up 2 2 in my y direction. So I can write my new coordinate as this. So then what you can do, if you just know the points, if you knew that point B, so let's write B was -1, -1. When we transform that point and we plug in here, we have -1 plus 5 and -1 plus 2. Our new point gives us 4, 1. And we can check. If we start at 0, 0, go over 1, 2, 3, 4, up 1, that's our new point B. So this would be B prime. Remember, B prime is read as B prime. Okay, so that's how we use coordinate form for our translations. So let's look at an example. Okay, in this example it says graph quadrilateral HJLK, where it lists our points and it's translated by this coordinate form translation. So it looks like we're going -3 in our x direction, so that means I'm going left 3, and my y is +3, so that means I'm going up 3. So plus means up, minus means left. List the coordinates of the image and then graph. Okay, so if I'm taking my original points and I want to translate it by this coordinate form here, I'm going to take my first point H, I'm going to subtract 3 from my x, so I have -1 minus 3, and add 3 to my y, 0 plus 3, which gives me -1 minus 3, -4, and 0 plus 3 is 3. This is my H prime, so I'm just going to make some room to write that in there. 0 plus 3. H prime is -4, 3. Let's do the same for J. So J, I'm going to get my J prime. 0 minus 3 is -3. 2 plus 3 is 5. L prime, 3 minus 3 is 0. 1 plus 3 is 4. Last one, K prime. 2 minus 3 is -1, and -2 plus 3 is +1. So now I have my 4 new points. So I can graph my pre-image and my image. I'm going to start with my pre-image, and I'm going to do those in red so you can see. If we have H is -1, 0. J is 0, 2. L is 3, 1. And K is down 2, right 2, down 2. Okay, so remember our points are always in XY form. If I have a negative, means I'm going left in my X direction. If I have positive, means I'm going right in my X direction. I always want to do my X first and then my Y. Now I have them all drawn, so I'm going to connect my quadrilateral. Now I'm going to graph my translation. And remember, these points over here are my translation. I have -4, so count 1, 2, 3, 4 to the left, up 3, 1, 2, 3. -3, 5, 1, 2, 3, up 5, 1, 2, 3, 4, 5. 0, 4, 1, 2, 3, 4. And then -1, 1. And again, I can connect all my points. And you see we have the same image, it's just been translated up.
You'll need to unlock your.
So if we have our points labeled, this would be H prime, J prime, L prime, and K prime. And our H, J, L, and K. That would be our answer. Okay, let's do the next example. This one is not asking us to graph. This one is just asking us to find the new coordinates of our triangle. And it says triangle TUV has vertices translated 3 units up. So that means up, that's my y direction. And if I'm going up, that's positive y. So I'm going to add 3 to my y and 5 units left. So if I go left, that is my negative x direction. So that means I'm going to take my x and subtract 5. Okay, so if I write my new coordinate transformation up top here, I'm going to get x minus 5 and y plus 3. Then all I have to do is take my points. Now if I look at them, if they give me t prime is negative 6 minus 1, that means they're already giving me my image. So if I already have my image, I'm going backwards. I'm trying to find my pre-image. So the way I'm going to do that is if I start with t prime, my x is negative 6. Well, I know that this is what that negative 6 equals. I should have my x minus 5 equals negative 6. I used that transformation to get that negative 6 value. So now I can solve for x by adding 5 to both sides. When I do that, get x equals negative 1. That means my original point of t had an x of negative 1. If we do the same thing with the y, my y for my image is negative 1. To find my original one, I gotta subtract 3. Y is negative 4. So this means my original point, my pre-image point of t was negative 1, negative 4. And if you want to check that, you can check that if we plug these into our transformation up top, negative 1 minus 5 gives us negative 6. Negative 4 plus 3 gives us negative 1, which is our t prime point up here. Okay, so then we have to do that same process for point U and point V. So if we look at U prime, we have x minus 5 is equal to 1. This means we add 5 to both sides, x equals 6, and y plus 3 is going to equal 5. So if we subtract 3, y equals 2. So we get 6, 2 for u. And our last point, v prime, x minus 5 equals 0. Add 5 to both sides. X equals 5. And then y plus 3 is negative 2 minus 3. Y is negative 5. So our original v point, our pre-image, was 5, negative 5. And these are our 3 original points. One more thing to note down here at the bottom if you have an image or a pre-image that is translated more than once, sometimes you might translate it one time in one direction and then another time in another direction. That would be called a composition. So a translation made up of successive translations, that means a bunch of translations in a row, is called a composition. Okay, we've got one more example at the bottom. This example, rectangle with M and PQ with vertices listed here, is translated down 4, so that means my y direction, I'm going down 4, so I'm going to subtract, and right 6, that means I'm going in the positive x direction, so I'm going to have x plus 6. Then the image is translated up 3. See, up 3, that's going to be plus 2 in my y direction, and left 7. Left is negative x, so that is going to be x minus 7. Write the coordinate form of each translation and then the composition. Okay, I'm going to start by listing my points up at the top. So if I have m, negative 3, negative 1, n, 1, negative 1, p is 1, 4, and q, negative 3, 4. Okay, so it wants me to list each transformation. So my first transformation, I start with my original point, and I'm going to do this first. I have y minus 4 and x plus 6. So x goes first, y minus 4. When I do that, I'm going to get my m prime. Negative 3 plus 6 is 3. Negative 1 minus 4 is negative 5. N prime. 1 plus 6 is 7. Negative 1 minus 4, negative 5. 1 plus 6 is 7. 4 minus 4 is 0. This should be p prime here. Then q prime. Negative 3 plus 6 is 3. 4 minus 4 is 0. So that is my first transformation. Then I'm going to take that and transform it again. So the way I'm going to write that is taking my new x prime, y prime, and I'm going to translate it here this time. I have x minus 7, which is x prime minus 7, and then y prime plus 2. Okay, so now when I start with my m prime, I'm going to subtract 7. So since we've already used prime, my next step is going to be m double prime. 2 prime symbols. That's how we read that. M double prime. 3 minus 7, negative 4. Negative 5 plus 2 is negative 3. N double prime. 7 minus 7 is 0. Negative 5 plus 2 is negative 3. P double prime. 7 minus 7 is 0. 0 plus 2 is 2. And then Q double prime. 3 minus 7, negative 4. 0 plus 2 is 2. Okay, and I'm just going to note over here, we read this as Q double prime. Okay, so this is our answer. This is where our point is going to end up, right here. Now, this asks you to show each step, but you could combine those two transformations and just do it once. So if we were to do that, combine these transformations right here. Our transformation would be taking x and y, and you have x plus 6 and minus 7. X plus 6 minus 7, and y minus 4 plus 2. You could simplify this. X and 6 minus 7 is just minus 1. Y minus 4 plus 2 is a minus 2. And this transformation would give you the same thing that doing both those steps would. If you wanted to try it, start with this original points up here. Our m double prime would be negative 3 minus 1 is negative 4. Negative 1 minus 2 is negative 3. So we started with this point up here. We took negative 3 minus 1, negative 1 minus 2, and you see we got the same thing in both cases. And you would get the same thing for those other 3 points.